Hello. In this video we're going to simplify square roots, or radicals, with variables. In this video it's assumed that you already know how to simplify square roots with whole numbers, so we're just going to jump right into the variables part of it. So again, just to remind you, the first step of simplifying a radical is to factor what's under the radical, and then we look for perfect squares. Now when we're working with variables, anything with an even exponent, any variable with an even exponent, is actually a perfect square. When we find a perfect square, we're going to remove the square root. We're going to take the square root of it and then put it outside the radical symbol. Another thing you want to do is look for pairs. Now, you probably won't see any pairs if you found the perfect squares already, but sometimes you miss the perfect squares, in which case you have to go for the pairs. If you see a pair, you cross one out and bring one out. And then you're going to keep factoring until you can't do number 2 or number 3 anymore. Now the thing when you're working with variables is you have to do several different layers of thinking. One layer is the whole numbers. The other layer is say, the x variable, and another layer might be the y variables. So you want to separate your thinking between your whole numbers and each variable. You want to just process them each isolated from the rest. All right? So let's try some problems. Over here on the left, we have the the square root of z cubed. So if we just want to factor z cubed, now I'm going to do this the long way. Z times z times z. Now, if we follow the procedure that we've been doing, we look for a pair. I see a pair of z's. I'm going to cross one out and bring one out. So one z comes in front of the radical, and one z was left behind underneath the radical. And the final answer is z root z. Now, the other way of doing this is to look for a perfect square. Now, z squared is a perfect square. So let's solve this problem again. We're going to factor z cubed into z squared times z. Notice now we have a perfect square. And that perfect square, z squared, can be, you can take the square root of it. So the square root of z squared is z. And then what's left underneath the radical? Another z. So again, we have z root z. We just solved this problem twice using two different techniques. You're going to want to look at the exponents in terms of perfect squares. You don't want to always write all the exponents out or all the variables out repeatedly. And you'll see this pretty soon. Let's take a look at the second problem, which is 9x squared, the square root of 9x squared. Now, if you want to do this very quickly, you recognize we have two perfect squares. But let's say you didn't see the perfect squares. Let's say you factored it. So we have 3 times 3 times x times x. And again, if you just go to taking a look at pairs, we have a pair of 3's. We're going to cross the 3 out and bring a 3 out. We're going to cross out an x and bring out an x. So we're going to end up with a 3 outside the radical and an x outside the radical, and there's nothing left under the radical, so we don't actually write the radical at all. So the final answer is 3x. Now let's say we did recognize perfect squares. What you can do in this situation is you can recognize that we have a 9. What's the square root of 9? 3. And what's the square root of x squared? X. So you could have gotten 3x, the final answer 3x, very quickly by recognizing perfect squares. Let's take a look at this next problem, which was given as the example in the title of our video. The rule says that we're supposed to factor what's under the radical. So again, we're going to look for perfect squares, but we are going to factor. So this is a 2 times 4, and then here we have an x squared times y. Now you don't always have to write out everything in broken down form. In this case, I'm looking for perfect squares. Perfect square is 4, and a perfect square here is x squared. So what's the square root of 4? 2. So that's going to join the other 2 already out in front. And what's the square root of x squared? That's just x. So what's left underneath the radical is another 2 and a y. So our final answer here would be 4x root 2y. 4x root 2y. Now, what if we have something that has a larger radical, like y to the 7th? This is something I do not recommend that you do. I do not recommend that you write y 7 times, because this gets very tedious. If you had a number larger than y, So this is y times y times y times y times y times y. This will get very tedious. So you don't want to do it this way. Plus, it's really easy to lose track of what you've crossed out and what you've brought up. I'm bringing out a y, crossing out a y, bringing out a y, crossing out a y. So I'm left with just one y under the radical, but three y's came outside. Y times y times y, aka y cubed. So the final answer is y cubed root y. But let's try this problem again. The square root of y squared. I'm sorry, not y squared. The square root of y to the 7th. Now let's try this again, but this time let's actually look for a perfect square. What's a perfect square inside of y to the 7th? That would be y cubed times itself. Y cubed. Or, let me back up a second. Let's actually write y to the 6th times 1. I'm sorry, y to the 1st. So if we have y to the 6th times y to the 1st, that actually makes y to the 7th. And y to the 6th is a perfect square. So what is the square root of y to the 6th? The square root of y to the 6th is y cubed. And then in this case, y stays underneath the radical. So again, I'm left with y cubed root y. Final answer. All right, let's do another one that has a whole number and then an x and a y. And in this case, let's go back to the tip that I gave you earlier, which says separate your thinking. If you could separate your thinking between the whole numbers and each variable, sometimes it's a lot easier to process than trying to look at everything all at the same time. So in this case, we're going to just take a look at the 12. So let's just do this, do a big radical sign. And let's just focus in on the 12. In fact, I'll do several radical signs. 12 is 4 times 3. And the square root of 4 is 2. So 2 will come outside of the radical, and 3 will stay behind underneath the radical. Let's actually give me some room. I'm going to put a 2 outside the radical. I'm going to put a 3 under the radical. Now let's switch colors and take a look at the x's. X cubed can be written as x squared times x. X squared is a perfect square, so an x is going to come out of the radical, and an x stays behind. And then lastly, we have y to the 4th. Now y to the 4th is a perfect square, but just for illustrative purposes, I'm going to write y squared times y squared. So it should be clear that I've got a pair of y squareds. One of them is going to come out. One of them gets crossed out. So y squared. And so here's our final answer. 2xy squared root 3x. I didn't need that bit of a large radical. Let's do one which involves multiplication. Like in the previous video, when we had one with multiplication, you can actually use the rule that says that you can combine what's underneath the radical signs because they're both square roots. So this would be a 2x times 10x. I'm going to write it as 2 times 10 times x, all right, or x squared. But again, we're going to factor what's underneath the radical. So 2 times 10 can be rewritten as 2 times 2 times 5. And I could just leave x times x. And now I look for either perfect squares or pairs. If I see a pair of 2's, I'm going to cross out one of the 2's, I'll bring a 2 out. So 2 comes outside of the radical. I also see a pair of x's. I'm going to bring one out, cross one out. And lastly, I have a root 5. So the final answer is 2x root 5. Now there is a pitfall, and you really need to watch out for this. Sometimes you'll see something where you'll see what looks like perfect squares. 25 is a perfect square, and 9 is a perfect square. So sometimes people will say, well, the square root of 25 is 5, and the square root of 9 is 3. Now this is not the correct answer. This is not the correct answer. All right? We are not trying to take the square root of 9. We're trying to take the square root of x to the 9th. And the square root of x to the 9th, you can either break it down or you can find a perfect square inside of it. But just like 25 is 5 times 5, x to the 9th can be written x to the 4th times x to the 4th times x. Right? So if we want to look for perfect squares, We can't. I'm sorry, if we look for pairs, there's a pair of 5s, so 5 comes out just like it did in our original problem. And here's an x to the 4th which comes out. The other x to the 4th gets crossed out. And then lastly, we have an x which stays underneath the radical. So that is a very common mistake that students make. They're so focused on looking for perfect squares that they correctly say that 25 is a perfect square, but they incorrectly say that 9 is a perfect square, because that's not a 9 at all. It's an x to the 9th. And x to the 9th is not a perfect square. So please be careful with that.